Have you ever wondered how our home galaxy, the Milky Way, came into being? Nearly 13.6 billion years ago, the universe set the stage for an event of cosmic proportions. Right after the Big Bang, the universe was a hot, dense soup of particles. As it expanded and cooled, structures began to form within this cosmic soup. Dark matter, an invisible and mysterious substance, clumped together under the force of gravity, creating a cosmic web. Within these dark matter halos, gas began to accumulate, forming dense, cold molecular clouds. These clouds, rich in hydrogen and helium, are the birthplaces of stars. As the clouds collapsed under their own gravity, the first stars ignited, their fiery light piercing the darkness of the early universe. These first-generation stars, known as Population 3 stars, marked the earliest stages of our Milky Way's formation. Thus began the birth of the Milky Way, setting the stage for a universe of possibilities. So how did the Milky Way evolve from a primordial cloud to the spiral galaxy we know today? Here's the fascinating story. The formation of the Milky Way was a process that unfolded over billions of years, a grand ballet of cosmic forces and materials. The early galaxy was a chaotic mix of gas and dust. But gravity, the great choreographer of the cosmos, began to mold this raw material into something more structured. Gravity pulled the gas and dust together, creating dense regions that would become the breeding grounds for stars. As these regions contracted under their own weight, their cores heated up, igniting nuclear fusion and giving birth to the first stars of the Milky Way. These stellar newborns in turn started to form clusters, gravitationally bound groups of stars born from the same molecular cloud. But the evolution of the Milky Way didn't stop at star formation. As stars formed, they began to organize themselves into an intricate spiral structure, the hallmark of our galaxy. This wasn't a random arrangement. The spirals are density waves, regions of increased star formation, shaped by the gravitational forces within the galaxy. As stars orbit the galactic center, they move in and out of these density waves, lighting up the spiral arms like a cosmic carousel. Meanwhile, the cycle of stellar evolution played a crucial role in the galaxy's growth. Stars, after burning through their nuclear fuel, would explode as supernovae, dispersing their enriched guts back into the galaxy. This stellar debris, laced with heavy elements, would then be recycled into the next generation of stars and planets, contributing to the chemical complexity of the Milky Way. In this way, our galaxy grew and evolved, from a primordial cloud of gas and dust to a bustling metropolis of stars, bound together by gravity and lit up by the fires of countless suns. It's a continuing process, a cosmic dance choreographed by the laws of physics and played out over billions of years. The Milky Way, as we know it, began to take shape, growing and evolving over billions of years. And the dance continues as the galaxy we call home keeps evolving, one star at a time. Stars, the building blocks of our galaxy, have an intriguing story of their own. The Milky Way has been a cosmic cradle to a diverse array of stars, each with its unique tale etched into the galaxy's timeline. Let's start at the beginning with the first-generation stars, known as Population 3 stars. These ancient giants, composed solely of hydrogen and helium, set the stage for the stellar generations to come. As these stars ended their lives, they left behind heavier elements, the stardust from which new stars were born. This led to the formation of Population 2 stars, our galaxy's middle children, if you will. These stars, enriched with heavier elements, brought diversity to the Milky Way. Fast forward to the present, and we find the youthful Population 1 stars. These youngsters, still forming in stellar nurseries, are the most metal-rich stars in our galaxy, continuing the cycle of stellar birth and death. From ancient stars to newborns, each generation contributes to the rich tapestry of our galaxy. The Milky Way is not a static structure, it's dynamic, changing, and evolving over time. Let's delve into the dynamic forces that have shaped our galaxy's structure and behavior over the eons. One of the most influential forces at play is gravity. It's the stage director of the cosmic ballet, choreographing the dance of celestial bodies. Gravity is what initially pulled together the gas and dust that formed our galaxy. It's also responsible for the spiral shape of the Milky Way, keeping everything from the smallest stars to the largest celestial bodies in their respective orbits. But gravity doesn't only act within our galaxy, it also governs the interactions between the Milky Way and its cosmic neighbors. These gravitational tugs of war can cause dramatic changes in the shape and structure of our galaxy, such as warping, stretching, or even triggering new rounds of star formation. Speaking of star formation, it's another key player in the game of galactic dynamics. Stars are born when dense sections of nebulae collapse under their own gravity, heating up and sparking into life. This process not only populates the galaxy with stars, but also influences its overall structure. You see, the birth of stars isn't a quiet event. It can send shockwaves through the surrounding gas and dust, triggering further star formation and creating intricate patterns in the galactic disk. Now let's not forget the explosive deaths of stars, supernova explosions. These cataclysmic events scatter heavy elements across the galaxy, seeding future generations of stars and planets. Supernovae also release enormous amounts of energy, which can blow away surrounding gas and dust, shaping the galactic landscape. Finally, we come to the mysterious and intriguing black holes. These gravitational giants, particularly the supermassive one lurking at the heart of the Milky Way, play a crucial role in our galaxy's dynamics. They influence the orbits of nearby stars and can even regulate the rate of star formation. These dynamic forces contribute to the constant evolution and transformation of the Milky Way. Our galaxy's history is marked by tumultuous events, including collisions and mergers. These aren't just rare occurrences, they are fundamental chapters in the tale of the Milky Way. Take disrupted satellite galaxies, for instance. These are smaller galaxies that were once minding their own business until, well, they wandered a bit too close to the Milky Way. The gravitational forces at play cause these galaxies to stretch out, eventually tearing them apart and leaving behind only traces of their former selves. And let's not forget about the accretion of dwarf galaxies. These are smaller galaxies that get gradually pulled into the Milky Way, their stars slowly becoming part of our galaxy's structure. It's a cosmic dance of sorts, where galaxies pirouette around each other until they inevitably merge, contributing to the ever-evolving portrait of the Milky Way. These cosmic collisions and mergers have left indelible marks on the Milky Way. Fast forward to today, what does the Milky Way look like? Our galactic home, in its modern form, is a spectacle of cosmic artistry. The Milky Way is a barred spiral galaxy, a celestial canvas painted with vast arms of stars, gas, and dust, spiraling around a dense central bulge. This bulge houses an older population of stars, while the spiral arms are vibrant with younger stars, a testament to our galaxy's ongoing star formation. These newborn stars light up the nebulous nurseries they emerge from, creating a dazzling display of cosmic fireworks. Meanwhile, the Milky Way's stellar populations are as diverse as they are numerous. From hot, short-lived blue stars to cooler, long-lived red ones, our galaxy is a cosmic melting pot of stellar life stages. And let's not forget the integral role of stellar evolution. Stars are born, they live, and they die, often in spectacular fashion, contributing to the ongoing transformation of the Milky Way. The Milky Way continues to evolve and transform, a testament to the dynamism of the cosmos. What lies ahead for our galaxy in the distant future? As we gaze into the cosmic crystal ball, we see a future filled with change, transformation, and perhaps even rebirth. The Milky Way, like all galaxies, is not a static entity, but an ever-evolving celestial body. It's projected to continue its dance with the surrounding cosmic environment, pulling in, consuming, and being influenced by smaller neighboring galaxies. In about 4 billion years, a significant event is predicted to unfold: the merging of the Milky Way with the Andromeda Galaxy. This colossal cosmic collision will dramatically reshape our galactic home, birthing a new elliptical galaxy from the remnants of the two spirals. Beyond this, the Milky Way's future is shaped by the broader cosmic timeline, governed by the laws of physics and the relentless march of cosmic evolution. The future of the Milky Way is as intriguing as its past, a journey we continue to explore. Our journey through the history of the Milky Way brings us to the present, teeming with questions about the future. From the early stages of formation, our galaxy has been a cosmic tapestry, intricately woven with the threads of time, space, and matter. We've traced the origins of our galaxy's precursor structures, journeyed through epochs of galactic evolution, and peered into the stellar nurseries. The Milky Way has been shaped and reshaped by dynamic forces, both internal and external, resulting in its current spiral structure. We've explored the evidence of past collisions and mergers, and the ongoing accretion of dwarf galaxies. Today, our galaxy continues to evolve and interact with its cosmic environment, its future as fascinating as its past. As we gaze upon the vast expanse of space, we're inspired to contemplate our place within it, to unravel the mysteries it holds. The Milky Way's tale is a cosmic narrative, a testament to the grandeur and mystery of the universe we inhabit.